Hello everyone, welcome back to the channel. So in the previous video we understood the concept of binary search. So in this video we will take one step further and we will solve a problem on binary search. So basically the problem states that we have to find the insert position in sorted array. What does it mean? So basically it means that we have to find the insert position for element, like where the element should be inserted in the array. So suppose here we have to find the insert position for 3. So in this array 3 will be after 2, so we have to return the index 1 because 2 is the 0th index, so we will return the index 1. And if you like, and if the element already exists in the array, so suppose we are like 5, we have to find the insert position for 5 and 5 already exists in the array, then we will just return the index of the element. So suppose there are like 5 5 5 like these, and if like we go to these 5 or these 5, we can return any of the index, like because we can insert 5 at any of these index. So basically the core idea is that we have understand the concept of binary search. What it do is that it will pick the middle element and then will partition the array. So in this we will do the same. For that, what we will do is like we will find the element and then we will compare the element. So first the case will be like we will find the mid. So here how we calculate the mid element by summing of low and high, the left and right, sorry, the left and right, and we will sum of the index, and then we will divide the index by 2. So now the case will be like if the element already exists in the array, then we will just simply return the mid. So what we will do is like if nums of mid, like the value at nums of mid is equal to num, so in that case we just basically return mid. Now the next case will be like if else if else and else if the value, like the value at nums of mid is greater than the value that we are looking for. So the value is greater. So suppose we are like we want to insert 24, and here the middle element will be 12 and we are trying to insert 24. So basically 24 is will be on the right side, or inserted will be on the right side. So we will eliminate this part of the array and we will go to there. So here the low sorry, my bad, I just explained it for this. So if that is the case, like the num is greater than the middle value, then what we will do is we will increment the low, increment the left pointer to mid plus 1, so the left will be shifted to here. Now else, in the else what we will do is we will shift the right to mid minus 1, and then we will just simply return the left pointer. So how it is working, like suppose we are at 12 and we will find like a middle element and we will compare it with the value that we want to insert. So here 3 is the value, so it will go to left. So basically it just eliminate this part of the array and it will go to this part. Okay, now it will take 5 as the middle element, and now it will compare 5 with 3. So is 5 greater than 3 or less than 3? So basically 5 is greater than 3. So here 5 is greater than 3. So in this part 2 we will shift the left to mid plus 1. Num set mid is less than the nums. So the value is the value at mid is greater than num. So what we will do is we will shift the right pointer to mid minus 1. So the right will be shifted to 2. Now we will compare 2. Does 2 is 2 is greater than or less than 3? So basically 2 is less than 3. So in that case what it will do is it will increment the left to mid plus 1. So here the mid is 2, the left is 2, and the right is 2. So in that case it will just increment left by 1. So it will increment the left from 0 to 1, and we just simply return the value at left, sorry, the index left, which is the index uh, that we are going to like, or the value will be inserted. So I think you understand it with the dry run, and I think that's the enough information, because you already understand the concept. There is nothing like mm, the core idea is basically same. We will compare the value, and if it is less than, then we will eliminate the left part, and we just simply return the left index, because the left index is the index where we can insert the value. So here, like the concept, the fine, let's, and one more time understand the dry run. So we are looking for 3, so we will check for 12, if 12 is greater than or less than. So basically 12 is greater than, so in that case we will just eliminate the right part, as here mentioned. Right will become mid minus 1, so right will come here in the 8. Now again we will find the middle element, and if it is like greater or less, it is greater again, so we will just eliminate the right part. The right part is from 5 to 4, so there was only one element 2 left. Now 2 is the left and right and mid as well. So in that case we will compare it with the number. So if the number is like greater than or less than, so here the number is less than. So in that case we will just simply increment left with mid plus 1. So here mid is 0, so we will left is 0, so we will increment left by 1, so left will become 1. So we will find the insert position for 3, that is 1. And if we find like we were looking for 12, and if we find 12 at the mid, then we just simply return the mid. Now let's run the code. I think I've done something wrong. No, not type mid. I think I did something wrong here, or anywhere in the, oh yes, I forgot the semicolon. Yep, so it returned 1, that is the index where we can insert 3. And if we write like 12, it will return us the index of the 12. It is 3, 0, 1, 2, and then 3. I think that's it for the video. If you do like the video, make sure to subscribe to the channel, and thanks for watching the video. Bye bye.